In this lesson, the two students you see here, Haleemah and ET, will explore a context of a tiled swimming pool. The water is shown in blue, and the border is in white. They will work to find the number of tiles in the border of the pool. This will help them meet the goal of this lesson, which is to generalize a relationship between the number of tiles on the side of a pool and the number of tiles in the border using algebra and making meaning of their algebra in the pool context.
Do either of you have an idea?
Yes, I think there's 40 tiles around the pool because in one line there's 40 tiles. I mean, there's 10 tiles. And there's, it's a square, so there's 4 sides.
Okay. So can you write down, show us like where the 10 is and write down what you did?
Yeah, so there's like 10, 10, 10 all around.
Okay, so what's the total?
40.
So Haleemah says there's 40 white tiles in the border. What do you think, AT? Do you agree or disagree with that?
I agree with Haleemah's decision to say that the square had 40 tiles.
Okay. So why don't you count 2 of the sides for me? So if you do the border and the 2 sides, how many should there be?
There should be 20.
Okay, count it and see.
I counted and there was 19 tiles.
Okay. AT, can you kind of show, like circle or do something to show which 2 sides you counted together? Yeah, okay, so there and there. And he says there's 19 in those 2 sides, not 20. So let's give Haleemah a minute to count.
Yeah, there is 19.
So why wasn't it 20?
I believe it wasn't 20 because we counted the corners as 10 and there's not an extra corner for every side.
What do you think about that, Haleemah?
I agree with him.
You do? So what do you want to do to, how many total white tiles do you think are in the border?
I'll draw it out. If there's 10 on these 2 sides, that means there's gonna have to be 8. Oops. There's gonna have to be 8 on these sides.
Oh, what's your reasoning?
Because you can't count the corners twice, so you go up and you count 10 on those 2 sides, and then there's 8 on the bottom and top.
Okay, so how many total white tiles are there in the border? And what's your thinking there?
My thinking here is we can add up the 2 10s to get 20, and then we add up the 2 8s to get 16, and then we can add up all the sides together, which should give us 36 tiles.
What do you think of that, Haleemah?
I agree.
And could either one of you get that combined into one equation?
Yeah.
Can you explain your thinking?
Well, there's 2 8s, so 8 times 2 plus 10 times 2.
And ET, what do you think of that? Because there wasn't multiplication before, there was just addition.
I think she made the problem way easier.
She did. Well, how so?
She used multiplication to make less addition problems.
Haleemah and ET got it. They found that a pool with 10 tiles on a side would have 36 total tiles in its border. Initially, they had taken the number of tiles on a side and multiplied it by the number of sides and got 40 tiles. But, as ET pointed out, that doesn't work with the overlapping corners. To correct their answer, they said that if there are 10 tiles on the right and left sides, then there would be 8 left on the top and the bottom. To find the total, they then added up all the numbers. When combining their work into an equation, they changed their method slightly. Did you catch that? Instead of writing 8 plus 8 plus 10 plus 10 equals 36, they wrote 8 times 2 plus 10 times 2 equals 36. They were able to make it easier because there were 2 8s, giving them 8 times 2, and 2 10s, giving them 10 times 2. In the next segment, Haleemah and ET will connect their expression back to the figure.
Well, we counted 10 on the west and the east side, and we counted 8 on the north and south side. So we decided to go ahead and multiply them 8 times 2 and 10 times 2 and add them together for the total amount of tiles on the outside.
Now, Haleemah, just so I'm sure I see where the 8 and the 10 are, could you draw a circle around the 10 tiles that ET said were on the west of the pool?
Yeah.
So it's those blue tiles?
Yeah, the ones that are circled.
And ETG, is that the way you saw it?
No, I'm gonna have to disagree with Haleemah.
So are you guys okay disagreeing?
Yeah.
Yes.
Yeah, I think that's very important mathematically. All right, you show us where you see the 10s.
I see the 10s right here
Oh, yeah.
and right here.
That is what I meant to do. I'm sorry.
You mean he convinced you already?
No, because I know it's like supposed to be the outside, like the border. I don't know what I did. I don't know what happened.
That's all right. So do you guys both agree that there are 10 in the 10 tiles in what ET just circled?
Yeah.
Okay.
Yes.
Haleemah, can you circle where the 8 tiles are?
Yeah.
ET, what do you think?
I agree with what she did.
Haleemah and ET have come up with a method of finding the number of tiles in the border of a pool with 10 tiles on a side. They saw 10 tiles on the left and right side, which is 10 times 2 in their equation, and combined that with the 8 tiles they saw on the top and bottom, which is represented by 8 times 2. In the next episode, Haleemah and ET will apply their method for finding the total number of tiles for different sized pools.